Next one is the RS nomenclature, RS configuration. RS configuration, this is absolute configuration, not taking any reference, absolute configuration. Absolute configuration. R means in the Latin language rectus. S means sinister. S full form is sinister. In Latin, this rectus means clockwise. This one is anti-clockwise. Anti-clockwise, sinister. But this is RS configuration which is proposed by the Kahn Ingold and Prelog. So by using these three, this nomenclature is also sometimes which is called as CIP configuration or CIP nomenclature. Kahn Ingold Prelog nomenclature. CIP configuration. Kahn Ingold Prelog. CIP. Right? R means rectus, clockwise, S is sinister, anti-clockwise, here it is. Now coming to the point of the RS configuration or absolute, in the earlier one of the DL configuration, only configuration will be assigned based on the bottommost asymmetric center or chiral center. But here the configuration in RS configuration will be assigned for all the asymmetric carbons, all the asymmetric centers or chiral carbons, all the asymmetric centers or chiral centers. All asymmetric centers or chiral center, RS configuration will be assigned. RS configuration will be assigned. So now here it is. What is the RS configuration? How it will be given the RS configuration? First, you can take the project the molecule on the Fischer form, or it may be the Newman, or it may be the Sahars, whatever they will be taken. Newman, Sahars, all those cases it may be wedge, it may be useful. Project the molecule on any one form, Fischer, wedge, Newman, Sahars. If it is Newman form is there, you can convert to that. It may be conversion to the one form to another form. Conversion also it may takes place. I will explain that. Based on that, Newman is going to be Fischer, or Sahars is going to be Fischer. Any one form you can identify that. Project the molecule. After that, project the molecule in any one that. Identify the chiral centers. This is it may be important. First, identify the chiral or asymmetric centers. Identify the chiral or asymmetric centers first. After identifying the chiral or asymmetric centers, based on the groups which is attached to the asymmetric centers or chiral centers, the groups or atoms or ligands which is attached to the asymmetric centers or chiral centers. Asymmetric center or chiral center, the groups which is attached to the asymmetric or chiral centers. Groups which is attached to the asymmetric or chiral centers, give the priority, assign the priority, give the priority or assign the priority based on atomic numbers. Based on atomic numbers. Based on the atomic numbers. Based on atomic numbers, give the priority or assign the priority for the groups which is attached to the asymmetric centers or chiral centers. Which is attached to the asymmetric centers or chiral centers. Give the priority based on the atomic numbers. Based on the atomic numbers. Give the priority based on the atomic numbers. That means for the asymmetric center or chiral center case, first give the more atomic number, give the first priority. More atomic number is more. Atomic number is more. Give the first priority. Give first priority And rest of the three groups also there. First, which one group you have to select? The atomic number of the atom or group, if it is there, more, that you have to select as more priority. And it is continuing on the rest of the three groups. Remaining three groups also there. You can continuing on that till the three groups. Priority is decided for the next three groups also. That means next, if it is one atomic number is given, first priority is over. First priority is there, second, third, fourth priority is also it may be necessary. So first atomic number is given, first priority, till give the priority for remaining groups also. Remaining groups also. Priority is given for the remaining groups or atoms which is attached to the chiral center. Based on atomic number. Based on atomic number is more, you give the first priority. Next, second, third, fourth. Till the priority is decided, you give the atomic numbering. Atomic number is more, give first priority or numbering till the priority is decided for the remaining groups. Till the priority is decided based on the remaining groups. After assigning the priority for the atomic numbers, based on the atomic numbers, keep the whatever that least priority group, that means fourth priority group. Four groups are there around the chiral center or asymmetric center. You give the based on the atomic number, 1, 2, 3 numbering is given. Based on the atomic number, 1, 2, 3, 4, first priority. So based on that, keep the least priority group. Keep the least priority group away from the observer. Away from the observer. Or if it is keep the least priority group at the vertical line. Keep the least priority group on vertical line. Based on that, keep the least priority group on vertical line or arrange on the vertical line. Keep the least priority group, arrange on vertical line. Then you check the priority direction. Check the priority direction. If priority is clockwise, this is important. Check the priority direction. If the priority is clockwise based on the atomic numbers, priority is clockwise, you give the clockwise is R configuration. For that molecule, you give the priority is clockwise R. If priority direction is anti-clockwise, suppose priority direction is anti-clockwise, you give the S configuration. Clockwise is R, anti-clockwise is S, for when the least priority group is at vertical line. Least priority group is at vertical line. If least priority group is not in vertical line, so you make that molecule, so that means the by interchanging the any two group, if least priority group or atom not on vertical line, suppose not on vertical line, what we have to use? Keep, that means by interchanging or by the exchange of two groups, two pair of groups, by exchange of two pairs of groups, then that least priority group, make that least priority group or arrange that least priority group by exchanging of the two pairs of groups, least priority group can arrange on vertical line or make that it is going to be vertical line. Suppose if it is FClHBr like that, if it is there, suppose. So by the atomic number, this is 1, this is 2, this is 3, this is 4. Least priority group is in horizontal line. It is not on vertical line. It is not on vertical line means which one group? Which is in horizontal line. Horizontal it may be there, not on vertical line. Then by exchange of these two following pairs, by the exchanging of the pairs, two pair of groups, Two pair of groups. Then this molecule is going to be, that means Br, F and H and Cl. By exchange of these two groups, then put into the least priority group on vertical line. Least priority group on vertical line. Then assign the priority based on the atomic numbers. If priority direction is clockwise or priority direction is anti-clockwise, S. Like this. The first rules which is prepared based on the vertical line. Least priority group on the vertical line, based on that clockwise is or anti-clockwise is. If it is not on vertical line, if it is an horizontal line, you make that by exchange of the two pairs, you make that molecule least priority group going to be vertical line. You make that molecule to that by exchanging of the two pairs. If it is, suppose if it is horizontal line is there, if it is in the horizontal line only, suppose, not on the vertical line, suppose if it is least priority group is in horizontal line, priority directions are opposites. Priority directions are opposite. If least priority group is on horizontal line, least priority group in horizontal line, then reverse of these configurations will be reverse. Configurations will be reversed means if priority direction, suppose clockwise, before if it is least priority in vertical line, or if it is horizontal line, yes. Check the direction of the groups. If it is anti-clockwise is there, if it is anti-clockwise, you give the R. Here it is anti-clockwise, yes. When it is least priority group is in vertical line. If least priority group is in horizontal line, reverse of that rules. Clockwise is yes, anti-clockwise is R. Next. For the priority direction, based on the atomic number, you give the first priority. If atomic numbers will be same, first atom atomic number is same, what we have to use? You go for the next atom atomic number. Next atom atomic number. First atom atomic number is same, first element is same, you go for the next one. Suppose H, OH, CH2Cl, CH2, F. What will happen? OH is oxygen, it may be there. First priority group, it may be there. Compared to the carbon, oxygen is more atomic number. Next, compared to the hydrogen, carbon is more. But these two carbons are same. Which one you have to give the priority? First connection is same, then you go for the next connection. Next connection is CH2. Next one is Cl and F will be there. So then Cl is having more atomic number than the F, greater atomic number value than the F. So you give the priority 2, and this is 3, and this is 4. Now coming to the case, here it is, direction is anti-clockwise. Direction is anti-clockwise. Clockwise is like this. Anti-clockwise is like this. Opposite to the clockwise, you can consider the general clockwise direction. Anti-clockwise is like this. This is anti-clockwise. When it is anti-clockwise direction which is there, and least priority group is in horizontal. Least priority group is in horizontal line. This is horizontal line, this is vertical line. Least priority group is horizontal. Least priority group is horizontal, anti-clockwise. Which one configuration you have to assign? R. Like that. If first priority, if it is priority direction, while giving the priority direction, if first connections are same, first elemental atoms will be same atomic number, you go for the next elemental atoms. If any isotopes are there, isotopic elements are there, if any isotopic elements are there, you give the priority based on the atomic masses. Give the priority based on atomic masses or atomic weights. Atomic weights or atomic masses. Atomic weights or atomic masses. Suppose hydrogen, deuterium, tritium and chlorine will be there. These are the same atomic number. Hydrogen, deuterium is also same atomic number, hydrogen isotope. Tritium is also same atomic number, hydrogen isotope. These three are the atomic number values are 1. Then which one you have to give this? If it is based on the atomic numbers, you already the rules will be proposed. If atomic number is same, which one you have to give? So that means based on the isotopic elements. Isotopic elements. So here it is. Fluoride is first totally because more atomic number. Then all or it may be having atomic number is 1. Then tritium is more atomic mass. Atomic mass is more, you give the first priority based on the atomic mass. So this is third priority, this is fourth priority. Tritium is more atomic number. So that means atomic number is atomic mass is more. Atomic mass is more, give the first priority. Give the first priority based on atomic masses. So what is that? 1, 2, 3. You go for that. 1, 2, 3. First 2, 1, 2, 3. You go for that. 1, 2, 3, 4 like this. So which one direction? This is anti-clockwise. Anti-clockwise, but least priority group in vertical line. When it is anti-clockwise, least priority group on vertical line, which one it may be there? Anti-clockwise is yes. S configuration. Right. Next one is the next rule is if at asymmetric center in asymmetric center or chiral center, asymmetric center or chiral center, the group which is having unsaturation or multiple bonds, the group having unsaturation of bonds or multiple bonds which is there. Group which is having unsaturation or multiple bonds are there. Then give duplications or do duplications, triplications. Do duplication or triplication of the bonds. Do duplication or triplication of the bond. Do duplication or triplication of the bonds means if it is unsaturation is there, suppose C double bond C is there. C double bond C. By the removal of one bond, one pi bond, these two atoms gets, each one two atom gets one new connection. So that is having duplication. In duplication, well, removal of the one pi bond and two new connections will be established. Like this, suppose 1 and 2. 1 and 2. So here it is will be given like this. 1, 2. The second carbon which is attached and first carbon is like this. C2 and C1. Here further it is making like that 0, 0, 0. What is that meaning of the 0, 0, 0 is phantom numbers. This 0, 0, 0 are called as phantom numbers. Phantom numbers. Phantom numbers means we assume every new atom which is having 4 bonds. We assume every new bond which is having established. If we assume every new bond, new atom which is going to be established, 4 new bonds are 4 linkages. So here it is only which is going to be only one linkage. Another 3 are not there, not established. Another 3 are going to be 0, 0, 0. Another 3 are zeros that indicated the phantom numbers. Only one bond is established and remaining 3 will be considered as zeros. So that's why this 0, 0, 0 indicating as phantom number. Right? Phantom number. So here it is. By the removal of one pi bond, 2 new linkages will be established. 2 new linkages will be established. C and C. The C is from the C2 carbon. The C is from the C1 carbon. This is called as duplication. Removal of one pi bond is equal to new connections will be established. Two new linkages will be established. Right? If it is suppose CH2 double bond NH, how we give the duplications for these duplications and triplication is only for the RS nomenclature point of view, configurations point of view. These are proposed rules for the RS nomenclature's case. Proposed rules for the RS nomenclature. How can you give this duplication? This N will be written here, and NH will be there. Here C will be written. Further, there is no connections. 0, 0, 0. Here N, here C. Removal of one pi bond. These two atoms gets one new connection each. Each one atom having one new connection. Each one atom. Right? So like this. Duplication. Not only this, C double bond O. C double bond O is going to be getting O is going to be C 0, 0, 0, and here it is O 0, 0, 0. Like this. O is also. In this position, oxygen. Imagine, in this position, carbon. Right? Triplication will be given for the removal of two pi bonds. For the removal of two pi bonds, four new bonds is established. Each one atom which is having two new linkages. Each one atom which is having two linkages. So like this, C triple bond N, C triple bond N. For the triplication, for the removal of one pi bond, one connection, another one pi bond is removed, takes place, another one connection. 0, 0, 0. These 0, zeros are phantom numbers. Further, there is no connections. That it may be having three connections will be 0. Right? So N, only one connection, remaining three is the zeros. Cn, linkages is 0, Nc. So Cn, N. Here N plus N is connected with the C and C by removal of two pi bonds. Right? So based on this type of priority will be assigning takes place. If it is C triple bond C is also like this. CH triple bond CH will be there. Suppose 1 and 2 carbons, you may imagine how can you give this priority? C 2 0 0 0. C1 0 0 0. C1. This place C2. Here it is also C2 0 0 0. Here it is also C1 0 0 0. Like this. Right? Acetylene also there. Suppose the molecule, I can give one example. HOH, C triple bond N, CH2 NH2. Right? First, based on the atomic numbers, you give the priority is 1. Next, which one it may be there? Carbon atoms will be there. Compared to the hydrogen, carbon atoms. But here triple bond is there. Here CH2 is there. Here triple bond is there. CN is here. CN is here. If duplication, triplication we are not given, suppose we may think that this is second priority, this is third priority, but it is not true. Right? Though it is CH2, NH2, hydrogens are there. Here it is, there is no hydrogens, but you give the priority 2 for this is 3 for 4. Why? Because C triple bond N we got to give the more priority. The C triple bond N which is indicating as carbon which is attached to the nitrogen atoms, 2 nitrogen atoms. and nitrogen which is attached to the 2 carbon atoms. Nitrogen which is going to be 2 carbon atoms. See, here it is, by using the like this C triple bond N. So here it is, which one it may be there? CH2 is there and NH2. Carbon is going to be attached to the 2 hydrogens. But this carbon is which one elements are there? Nitrogen, more atomic number. Carbon is going to be 2 nitrogens directly. But this carbon is 2 hydrogens only. So that's why you give the priority for the second based on the Bantham numbers. 0, 0, 0 and triplication, NN, nitrogen atoms will be there. Right? So this type, a number of examples later we can discuss by this format. So check them, priority direction is which one? 1, 2, 3. Anti-clockwise, least priority in horizontal. Which one it may be there? R. Generally anti-clockwise yes, but least priority in horizontal, rules will be reversed. Then it is R. Next. If R configuration group, S configuration groups are there, R configuration it may be, you can assign more priority than S configuration. Then S configuration. That it is having, suppose OH, R configuration group it may be there. Another one side is S configuration group is there. You give the priority for the 1, 2 for the R configuration group, 3 for the S configuration group. First you give the priority for the R configuration, later that S configuration. So if it is chiral centers it may be there. You can, for this case, for assigning the priority, suppose this is R, this is S. Which one you have to give in the priority directions? So you go for this R, it may be more priority than S. So you take this group R, this group is S, first priority, then second priority is like this. R gets more priority than S. R gets more priority than S. Next one, if it is, suppose if it is one side it may be RR configuration in the same molecule, within the molecule. If it is SS configurations are there, RR configuration you may consider or SS configurations you may consider as like configurations. RR configuration gets more priority than SS configuration. RR configuration gets more priority than SS configuration. Like this. That means if it is, so you can assign the priority direction. Here it is. Suppose this is RR, SS. So 1, if it is given, suppose 2 will be given like this RR instead of SS. Right? So number of examples I have given later. RR priority, RR gets more priority than SS. And then next one, like configuration, that it is having RR or SS gets more priority than unlike configuration. Like configuration gets more priority than unlike. Unlike means RS or SR combinations. RS or SR. RR or SS gets more priority than RS and SR configuration. Next, in the chiral center, the priority directions case, if atomic numbers are same and duplications are same, that means multiple bonds it may be same. Then if it is cis and trans type of configurations is there, cis gets more priority than trans. Cis gets more priority than trans. Cis gets more priority than trans. So that means if it is here, the molecule is like here it is there. This is trans type. This is cis type. Cis gets more priority than trans, like this. Right? Similarly, EZ will be there. Suppose Z gets more priority than E. EZ will be there. Z gets more priority than E. Z configuration. More priority than E. Like this type of rules will be used for the RS nomenclature point of view. So later we can the examples will be given. Which one is the R, which one is the S. This is the rules. Con in gold Prilog rules. Next one example is, suppose COOH, H, CH3. This is a familiar example, already we have seen number of times we have seen. And how can you, one, based on the atomic numbers, C is same, H is there, here it is, next priority is O, 2 and 3 and 4. Keep the least priority group actually, they are after, while seeing the deciding the priority direction, keep the least priority group on vertical line, then clockwise is R, anti-clockwise is S. Or keep the least priority group if it is above and below the plane is there, keep the least priority group is away from the observer. That is happening in the vertical line, away from the observer. Right? If it is horizontal line, clockwise is S, anti-clockwise is R. So here is least priority group is horizontal line. If it is clockwise, yes, anti-clockwise, R, reverse of that rule. So 1, 2, 3, 4. Priority direction is given 1, 2, 3. 1, 2, 3. Like this. Not this 1, 3, 4 like this. Not. So that's why 1, 2, 3. Like. So this direction is anti-clockwise. Least priority in horizontal. So which one it may be there? R. Generally anti-clockwise, yes, but least priority in horizontal, so that's why R. If it is NH2 methyl alanine, what will happen? This is lactic acid, this is alanine. So carbon, hydrogen, nitrogen. First, which one is atomic number is more? Nitrogen. Next, carbon atomic number. So then hydrogen is there. Next connection is oxygen. So here it is 2, 3, 4. Which one direction? 1, 2, 3. Clockwise. But least priority group in horizontal. Generally clockwise are vertical, but here it is least priority in horizontal. Clockwise is S. Clockwise is S. Suppose CHO glyceraldehyde, CH2OH, CH2OH, HOH. Carbon and oxygen. So here it is, first one it may be oxygen, atomic number is more. Second one priority is which one? Hydrogen, carbon. So carbon atoms are same, first connections are same. So you go for the next connections. Next connection is oxygen. One side is hydrogen, next this side is also oxygen. Again here it is oxygen, hydrogen is there, but here there is no hydrogen. Based on that, you don't come with one conclusion. See, because here it is, you identified that this group is having unsaturation, that is having double bond is there. Group having multiple bonds, you go for the duplications. That means which one it may be there? Like this meaning. So this meaning is what? Carbon is going to be with oxygen is going to be with carbon. So you go for this. One side is hydrogen, no problem. One side is oxygen, no problem. Another one side is hydrogen, but another one side is also oxygen. Like this. Carbon is both sides which is oxygen, but here is one side is oxygen. So then which one you have to, you give this 2 and you give the priority is 3 for the CH2OH and then it is 4. Right? So which one it may be there? 1, 2, 3. Connecting the priorities. Which one direction? Anti-clockwise. Least priority in horizontal. Which one it may be there? R. Right? Next one. Phenyl, OHH or Cl. Phenyl. Which one it may be there? First priority at this 2 chiral centers which is there. Identify the chiral centers. These 2 are chiral centers or asymmetric centers. Each one asymmetric center, which is all asymmetric centers having RS nomenclature, RS configuration will be given. See, here it is. You can take this suppose. Atomic number is 1, phenyl group. Suppose we may imagine like this. So for this, suppose 1 is given like this. 2 is given for hydrogen is not given because it is least priority. You give for the priority for this phenyl ring or this ring. Second priority is this or this. Which one it will be given? So you go for this. Suppose here it is, you may go for this carbon. Here it is carbon. This carbon is connecting to the carbon, and this side is also carbon which is there. Though it is C-double-bond-C, but carbon is there. You go for this Cl, it may be there here. So that's why you go for this 2 is like this and 3 is like this. Though duplication, but all are carbons. Here it is chlorine. More atomic number will be there. Monatomic number group. So then immediately you give this priority to the this bottom end. 2, 3, 4. Direction is which one? 1, 2, 3. Clockwise. Clockwise least priority in horizontal, that is S. Clockwise least priority in horizontal, that is S. Next 1. Here phenyl is there. Here it is. This group it may be there. So C like this. C. But Cl will be there. So that's why you give priority is 2. And this is 3. And this is 4. Then priority direction is 1, 2, 3. Anti-clockwise. Anti-clockwise least priority in horizontal, that is R. One is S configuration, one is R configuration. If in chiral centers, one is S, one is R, and plane of symmetry is also there. Same bonding connectivity is there. One is S, one is R. Same bonding connectivity. And adjacent chiral centers, opposite configuration, and plane of symmetry is there. This compound is which one? Meso. This compound is having meso compound. If it is active, will be there, suppose. If it is active, will be there. If it is active, will be there, suppose. Phenyl, ClH, H and Cl, phenyl. Here it is, there is no plane of symmetry. Though it is chiral centers, but plane of symmetry is not there. Plane of symmetry is there. Chiral centers, opposite configuration, plane of symmetry is there, meso, same bonding connectivity. Connectivity is same, HCl, 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 PL, phenyl, phenyl, but there is no plane of symmetry. It is not a meso compound, it is active compound. Optical rotation is there. See, here it is. This one is which one? 1. This ring is given 2, like this earlier one. This is given 3. This is 4. 1, 2, 3. Clockwise, but least priority in horizontal, that is S. This is opposite to this earlier one. This is 1. And this one direction is 2. And this is 3. And this is 4. So, which one direction? Again clockwise. 1, 2, 3, again clockwise, least priority in horizontal. Clockwise least priority in horizontal is S. Both are having same configuration, SS. Suppose this one is also active compound, there is no plane of symmetry. Same bonding connectivity is there. Same bonding connectivity is there. See, here it is. Here this configuration is what? 1, this is 2, this is 2 means this is entire skeleton. 3, 4. Priority direction is which one? This one. Anti-clockwise. Anti-clockwise least priority in horizontal, that is having R. Next we go for this one. This is 2, and this is 3, and this is 4. Direction is again anti-clockwise, least priority in horizontal. Which one it may be there? R. Same bonding connectivity is there. Same bonding connectivity is there. One is R, another one is S. These two are which one? Enantiomers. If it is single chiral center molecule, same bonding connectivity is there. Bonding connectivity is same, must and should. Otherwise, these two are different molecules. Bonding connectivity is same, single chiral center. Suppose one is R, one is S. That is also enantiomers. This is also enantiomers. If same bonding connectivity is there, plane of symmetry is there. One is S, one is R. That is having which one? Meso compound. That is having meso compound. That is having meso compound. Right? If it is same bonding connectivity is there, one is S, one is R, another one is R, another one is S. It is also plane of symmetry is there. That is the two are homomers. Two are homomers. If it is bonding connectivity is same, one is RR, one is S, one is R. These two are diastereomers. That means RR, RSS, SR is there. Or one is S, one is S, one is R, one is S. These two are also diastereomers. Bonding connectivities are same. Like these two, SS, RR, it may be there. Same bonding connectivity is there, and also plane of symmetry. Here it is mirror image also, it may be there. You can check that. Enantiomers. These two are which one? Enantiomers. Further, suppose this one, you can check that. This first one, suppose this is first one, this is second one, and this is third one. Second and third is enantiomers. First and second is which one? This is SR configuration. Right? This is which one? SS configuration. S R configuration, another one is SS configuration. These two are diastereomers. Because CLs will be there, but CLs are mesoactive. Always mesoactive relationship is which one? This is meso compound. Mesoactive is diastereomer. I mentioned that very diastereomers relationship point of view. One compound is meso, another one is active. Mesoactive relationship is always diastereomer. This is meso, this is active, diastereomer. Or if you don't know that meso active, so you go for the configurations. One is S, one is R. another one is SS. Bonding connectivities are same. That means Cl connection, C-phenyl connection, CH, like this. Spatial arrangement it may be different, but bonding connectivities are same. There is stereoisomers, right? So SR, SS will be there, that is having diastereomers. 1 and 2 is diastereomers. 1 and 3 is also diastereomer. SR configuration and RR. SR, RR. So then 1 and 3 is also meso, this is active. So here in this case, 1 and 2, 1 and 3 is diastereomers here. And 2 and 3 is enantiomers. 2 and 3 is enantiomers. 2 and 3 is enantiomers. Right. Next one example. Next one example. Bonding connectivities are same, otherwise it is not that. It is not like the enantiomer, it is not like the diastereomer. Because bonding connectivities are suppose entirely different, that is may mention the diastereomer, but here it is, the molecules it may be same. See, listen. If it is, next one is COOH, OHH, OHH, COOH. Which one it may be? The configuration is configuration at the chiral center. Sir, this though it is a meso compound, tartaric acid. I mentioned that meso compound is which one? Plane of symmetry is there. Opposite in the chiral centers, adjacent chiral centers which is having opposite configurations. One is S, another one is R. You can check them also, it may be same or not. You go for this oxygen is 1, C double bond OH, and here it is there. Which one you have to give the priority? Carbon, carbon is same. This side is only oxygen, but here both sides will be oxygen. So directly you can give this priority is 2, this is 3. Carbon, oxygen, carbon, oxygen. But another one side is also oxygen is there. Here carbon, but here it is carbon will be there. There is no oxygen on another one side, right? So that's why here it is. Which one it may be there? Second priority is like this. Third priority is like this. So this is 4. Which one? Anti-clockwise. Least priority is there. That is having R. Least priority in horizontal. This is 1, 2, 3, 4. This direction is clockwise. Least priority in horizontal. So which one this is? Chiral center is S. Plane of symmetry is there. One is R, one other one is S. That is having meso compound. Meso compound. COOH. This is also a meso compound, but here it is which one it may be there in the configurations. So which one it may be having configurations of the chiral centers. How many chiral centers? 3 chiral centers or asymmetric centers. First you go for this one. Carbon, carbon. Carbon is connecting to the oxygen, it is also oxygen. But next one side is oxygen, but next one side is carbon. So you give the priorities to connections, you go for the connections. You may practice on, then it may be perfect. Right? Which one it may be there? Anti-clockwise. Anti-clockwise generally R, but least priority in horizontal. So this one anti-clockwise generally S, but least priority in horizontal. So this is R. First one carbon is R. The second one chiral center is which one? Before that you go for the priority here. Why? Because you go for the priority here. Suppose you give the priority is 1. Suppose carbon, second priority is which one group? This one going to be carbon, carbon. OH, OH, H, H, COH, COH. Both are same. OH, H, this group and this group both will be same. Then priority is which one? Give you to priority. So that's why if it is there, first you go for the bottom end. So then 1, this is 2, second priority, this is third priority, this is fourth priority. Like this. So which one it may be there? 1, 2, 3. Direction is which one? Clockwise. But least priority in horizontal. So this is which one? Yes. So it is again HOH. Same bonding connectivity or same groups will be there. One is R configuration, one is S configuration. Then you give the priority direction. R gets more priority than S. I mentioned that earlier one. R gets more priority than S. Then for the middle carbon, middle asymmetric center, oxygen is given 1. Next priority is given for which group? R group. Second priority. First priority here, OH, second priority here. Next, this third priority, S configuration gives third priority, and this is fourth priority is hydrogen. Direction is which one? Anti-clockwise. Anti-clockwise, and least priority is in which one? Horizontal. So which one configuration is there? Anti-clockwise, least priority in horizontal. This is R. This is R. Right? Middle one carbon is also R. Right? So if it is, this is the earlier molecule. Here I make one sentence. This is R, this is S, this is R. Right? Now here it is. Plane of symmetry is there, it's okay. In adjacent chiral center, suppose you can select this one, asymmetric center. This is also asymmetric center. This is. In adjacent chiral centers, in this adjacent chiral centers, which is having different configurations. Adjacent chiral centers, which is having different chiral centers. So this you can select the center. Sorry, not adjacent. This you can select this center. You can select this center, chiral center. This center, asymmetric center or chiral center. Center attached to the different configurations. One is R, one is S. You can select this center, which is attached to the R, another one is S. Different configurations, same bonding connectivity. OH, COH, OH, COH. Yes, select a center, asymmetric center, which is attached to the different configurations. Different configuration center, which is attached to the different configurations. Different configuration R and S, and same bonding connectivity is there. Same bonding connectivity. This center, whatever the center we have to choose, that center which is called as pseudo-asymmetric center. Pseudo-asymmetric center. You can select a center which is attached to the different configurations, same bonding connectivity. So this is one is R. Suppose you can select this center. This center. One side is R, another one side is S. Center which is attached to the different configurations, same bonding connectivity. Same bonding connectivity. Same bonding connectivity. OH, 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 H, OH. Same bonding connectivity is there. HOH, HOH, HOH. This center which is called as pseudo-asymmetric center. Pseudo-asymmetric center. When pseudo-asymmetric center generally can be shown like the symbols gamma and small s, third letter S. So this is S or, sorry, letter small s or gamma. So this is gamma. I can show you the gamma. This is pseudo-asymmetric center. Pseudo-asymmetric center. Right? Next one, suppose bonding connectivity is same, then only that center will be having pseudo-asymmetric centers. Here. Which one? This is similar like this, R configuration. Similar like this, bottom end is S configuration. Next, this is which one configuration? Oxygen is given 1 and carbon. OH will be there, OH will be there. One side is again carbon, but one side is COOH. So that's why you give the first priority, and this is second, and this is third, and this is fourth. So which one it may be there? Anti-clockwise, least priority in horizontal. So this is also given, or anti-clockwise, least priority in horizontal, R. Now you go for this. Sorry, go for this one. Next connection, for which one it may be there? These two cases. Carbon, OH, OH, H, H. But another one side is carbon, but another one side is carbon. But here it is COOH group is there. COOH group. Right? But here it is OH groups are there. So that's why here it is which one you get priority? 2, and this is 3, and this is 4. Priority direction is which one? Anti-clockwise, sorry, clockwise. Least priority in horizontal, so this is also again yes. Then you give for the priority for this one. One side is which one groups will be there? Yes. Yes. This is R, this is R, RR and SS will be there. So here it is OH and H will be there. First priority is OH 1. Right? Then which one you have to give the priority? Second priority is which one? Because with respect to this asymmetric center, here it is 5 asymmetric center. This is asymmetric center, this is asymmetric center, 4 different substitutions. This is asymmetric center, this is asymmetric center, this is also asymmetric center, or chiral center. All are because 4 different groups will be there. Right? 5 asymmetric centers or chiral centers are there. These two no problem, directly you can give. These two no problem. But here, because these two connections will be same, HOH, 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 HOH will be same, COOH, COOH, then which one you give the first priority? Like this earlier one, we can decide it. One side is R, one side is S, you give the priority to the R. Similarly, one side is RR, one side is SS, you give the priority to the RR, is more priority than SS, like this, 2, 3, 4. That means if it is given OH is 1, this group is RR is second, and this is 3, this is 4. So 1, 2, 3, 4. So that means 1, 2, 3. Which one direction? Anti-clockwise. Anti-clockwise, least priority in horizontal. Anti-clockwise, least priority in horizontal. So this one is given which one? R. Anti-clockwise is generally S, but least priority in horizontal, then it is S. Sorry, and it is R. Right? Though it is also, this one is also, one side is RR, one side is SS. One side is R, one side is S. You can select this center, suppose, center which is attached to the different configurations. One is R, one is S. Bonding connectivity is same, HOH, 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 COH, bonding connectivity is same. This middle center is also called as pseudo-asymmetric center. Pseudo-asymmetric center. Particularly configuration is R. Then it is pseudo-asymmetric centers generally can be showing that gamma or small s. Gamma it may be there. That is having pseudo-asymmetric center. So R gets more priority than S. RR gets more priority than SS. If it is RR or SS will be there. Like configuration one side, SR is one side. RR or SS. Like configuration is more priority than unlike configuration. RS or SR type. That is also having another one phenomenon. Examples. Suppose another one more example. COOH, methyl H OH. This is not wedge form. This is not generally, this is wedge form, it may be there. Wedge form. These two are in plane groups, these two are out of plane groups. One is above the plane or front of the plane, another one is below the plane or bottom of the plane. This wedge form. The RS configuration you may given to the wedge form also. Not only the Fisher form, wedge forms also given. Newman and SARS, everyone can give the RS nomenclature, every configuration, every representation. So now here it is, which one? It is given. 1. Again carbon, hydrogens are there. Here it is oxygen, it may be there. It is there. So wedge form case, priority will be decided. O, which is first priority. Oxygen atomic number is more. And carbon, oxygen, hydrogen is there. So I give the priority 2, and this is 3, and this is 4. Now if it is, the least priority group is, you may say that least priority group is either it may be the vertical line or horizontal line. Generally the least priority group is in vertical line, because above the plane and below the plane it may be mentioned like the vertical line. Before that, if it is given like this, least priority group is away from the observer. You apply the rules of the vertical line. Least priority is vertical line, clockwise is S, clockwise is R, anti-clockwise is S. Same thing will be applied for the least priority group is away from the observer. This broken wedge indicates away from the observer. The thick wedge is nearer to the observer, or front of the plane, or above the plane, below the plane, or bottom of the plane, or away from the observer. So if it is clockwise is there, generally R, anti-clockwise, yes, same rule, whatever the rule we can apply for the vertical line, same thing. Least priority group is in away from the observer. This is away from the observer. So then you give the priority 1, 2, 3. 1, 2, 3. Which direction? This is anti-clockwise. Anti-clockwise, least priority in away from the observer. So which one it may be there? Configuration is yes. Configuration is yes. Suppose next one. COOH, alanine, CH3, NH2, H. Or if it is H, here it is NH2. What will happen? Which one configuration? S-metric center is there, S-metric center. Because 4 different groups or atoms will be there. First, nitrogen atomic number is more. First give the priority. Then carbon. Later oxygen is there, hydrogens are there. You go for this 2, and this is 3, and this is 4. Check the direction is which one? Anti-clockwise. Direction is anti-clockwise, but least priority group is in which one? Nearer to the observer. Least priority group is away from the observer like this. If least priority group is nearer to the observer, these rules are reversed. Least priority group is nearer to the observer, rules are reversed. If least priority group nearer to the observer, that means which one? Thick line. Clockwise is there, which one? You give the S. Anti-clockwise, you give that R. That means similar like this. Horizontal line. Like this horizontal. So least priority group is nearer to the observer. Always arrange least priority group is away from the observer. That is the condition, RS nomenclature. Right? But here it is least priority group is nearer to the observer. Then rules are reversed. Then anti-clockwise, generally yes, but this is nearer to the observer, thick line, so that's why it is R. Next one. Next example. Next one example, suppose OH. If it is OH is there, that means that H is bottom of the plane, top of the plane, bottom of the plane, right? Above and below, right? So now here it is, to give the nomenclature, RS nomenclature, this is the chiral center or symmetric center. For the atomic number point of view, oxygen is 1, O, because carbon is there and hydrogen is there. First give the priority to the OH. Second one, here carbon, right? But carbon is attached to the 2 hydrogens, right? Here it is double bond which is there. This double bond is indicating C double bond O is there, which means that for the duplications point of view, like this, carbon is going to be attached to the oxygen. Here O, here C is there. Duplications, multiple bonds will be there, or unsaturation which is there, duplication. So that's why instead of this, we give the priority to the 2, and this is 3, and hydrogen is 4. Hydrogen is 4. Hydrogen you may write here, no problem. Because to assign the priority to the 1, 2, 3, last one is 4th. So that's why 1, 2, 3, the direction is which one? Anti-clockwise. Direction is anti-clockwise, and least priority group is away from the observer or on the vertical line, away from the observer, OH top and H is bottom, like this, OH and H, right? Or this least priority group away from observer, broken wedge or dashed wedge it may be there, thick wedge or heavy wedge. This is broken wedge, away from the observer, least priority group. When least priority group away from the observer, anti-clockwise direction, so this configuration is which one? S. Configuration is S. Anti-clockwise direction, right? Next one. Similar one example, another one more example. C double one O. OH. OH means this hydrogen is above the plane, OH is below the plane. To assign the priority, it may be same like the earlier one. 1, 2, 3. Again clockwise. Anti-clockwise. Again anti-clockwise like this, anti-clockwise direction. But the question is, the least priority group hydrogen is not away from the observer. It is nearer to the observer because thick line will be there. According to the wedge representations, thick wedge or heavy wedge, that is nearer to the observer or above the plane, right? So nearer to the observer, least priority group, not away from the observer. When it is nearer to the observer, you must apply the horizontal line rules, or nearer to the observer, reverse of that away from the observer rules. So that means away from the observer, maybe there clockwise is R, anti-clockwise is S. But here it is nearer to the observer, clockwise is S, anti-clockwise is R. This is anti-clockwise. It is R. Then these two relationship is what? Enantiomeric relationship. Any single chiral center, RS nomenclature will having, so same molecule bonding connectivity is same, right? Any single chiral center, RS nomenclature which is having, which one? Enantiomer. Which one? Enantiomer. Right? Next one. Suppose this similar one. OH. Here which one is there? OH. Here it is chiral center or asymmetric center. 1, priority is 2, and this is 3, and this is 4. To give that priority order, which one direction? Clockwise direction. Clockwise direction. When it is going to be clockwise direction, and least priority group is which one? Least priority group is away from the observer. Away from the observer. So clockwise rotation, then it is give R. Then it is given R. Right? So clockwise rotation, then it is gives R. So these two are, which one it may be there? These two are, which one? So this is R, this, these two. These two are same, nothing but homomers. These two are homomers. While interchanging takes place, degree of rotations takes place, R and R. Single chiral center, same configuration is there, nothing but homomers. Nothing but homomers. Right? So this type of relationship is there. This type of relationship is also there. These two are homomers. Right? Next one. Next one example, suppose OH methyl NH2. OH methyl NH2. So here it is in this molecule, how many chiral centers or asymmetric centers will be there? 3 chiral centers. Here 4 different groups will be there. Here 4 different groups. Here 4 different groups. The point which is attached to the 4 different groups. A center which is attached to the 4 different groups, that is having asymmetric center or chiral center. Asymmetric or chiral center. Now for this configuration is what? OH is first priority, and here CH2 is same. Go for the CH is same. Then go for this connection is methyl. Go for the connection is NH2. So NH2 is, nitrogen is more atomic number than the methyl. So here it is, priority is 2, 3. And fourth priority is absolutely which one it may be there? Hydrogen atom. I have not mentioned that hydrogen atom means hydrogen is which one it may be there? Below the plane or away from the observer, because OH is in the top of the plane, hydrogen is below the plane, away from the observer. So then priority direction is which one? Clockwise. Priority direction is clockwise. Least priority group is away from the observer. So then which one it may be there? R. This configuration is R. Now here CH2, CH3 will be there. CH2 is connecting to the carbon. So that's why here it is first priority is like, second priority is going to be like, third priority is like, fourth priority is away from the observer, hydrogen, right? So the direction is which one? Direction is anti-clockwise. Least priority is away from the observer, anti-clockwise, which one it may be there? Yes configuration. Now here NH2 gets first priority, and CH2, here it is methyl, and here it is OH. So here it is 2 and 3. Direction is which one? Anti-clockwise. Anti-clockwise. Least priority in away from the observer. Anti-clockwise, least priority in away from the observer. Which one it may be there? Yes. This one is R, this one is S, this one is S. Suppose the same molecule OH, NH2, methyl. Which one it may be there? Configurations. Similar one. It is 1, 2, 3. Direction is which one? Clockwise. Similar like this, clockwise. But least priority group in, because OH is bottom of the ring or near, away from the observer. Then hydrogen is nearer to the observer. Fourth priority group is hydrogen, that is nearer to the observer. Thick line you may show that, because one is already dotted line. Dashed representation will be there, or broken representation, broken wedge or dashed wedge it may be there, or away from the observer. Another one, hydrogen is left, that is nearer to the observer. I have not mentioned that means hydrogen is like this. Least priority group in nearer to the observer, then clockwise direction it may be there, that is having which one it may be there? Yes. Generally clockwise are, but least priority group is nearer to the observer. Here it is which one? 1, 2, 3 anti-clockwise. But least priority group is again here it is also nearer to the observer. So which one configuration is it? R. It is also 1, 2, 3 anti-clockwise direction. Least priority group is nearer to the observer. Anti-clockwise least priority is nearer to the observer, R. Then these two, one is R, S, 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 R, R. These two relationships are which one it may be there? Enantiomer relationship. Because one is S, one is R, here S. Opposite, here S, here R, here S, here R. Both are mirror image type relationships also there. Non-superimposable type it may be there. That is having enantiomers. Enantiomers. Suppose one is OH, NH2, methyl is there. Here which one is there? These configurations are not changed, R. This is also R. Here which one configuration is there? You may imagine like this, R also. Because least priority group is already there. Right? Least priority group is away from the observer. All are R. Now you can take these two relationship is which one? One is S, R, 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 R. S, R is the difference it may be there. Here it is R plus is S it may be there. So remaining two are same. That is having which one it may be there? Diastereomers. 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 Next one. OH. OH is there. OH. OH is there. OH is there. Right? Or another one also you may write like this. OH. OH. Which one is meso, which one is active, and what is the, how many chiral centers are there, what is the configuration at chiral centers? Configuration at chiral centers. You go for this. This is a chiral center because OH is one group, methyl is one group, hydrogen is there, and this is different group. And here it is also chiral center will be there, chiral center or asymmetric center. Here chiral center or asymmetric center is there, so I give the priority is 1, and this one is 2 because here it is methyl, here it is connections are more, atomic number is more compared to this, 3, and least priority group is hydrogen is there, that is having 4th. So direction is which one? Clockwise. Least priority group is away from the observer. I have not mentioned that hydrogen means hydrogen is in the broken line or dotted line. H, that is away from the observer. Right? Clockwise, away from the observer, that is having R. Here, 1, 2, 3. Direction is which one? Again clockwise. Least priority is away from the observer. So which one it may be there? R. Now here, similar like this, R. Here, 1, 2, 3, and which one direction is there? Clockwise. But least priority is nearer to the observer because OH is in dotted line, hydrogen is thick line. Hydrogen is thick wedge. Hydrogen is thick wedge, that means nearer to the observer. Least priority group is hydrogen, that is nearer to the observer. Then clockwise is there, S. One is R, one is S. Here, 1, 2, 3. Direction is which one? Clockwise. Direction is clockwise, but least priority group is nearer to the observer. So that's why here it is S. Here it is similar like this, S. Here it is similar like this, S. Here it is similar like this, R. Right? Now, in the chiral centers, in adjacent chiral centers, Similar configuration is there, RR, that is having active. That is having active compound. See, listen. Suppose OH, methyl H, OH, H, methyl. This one is converted, suppose 1, 2, 3, direction is clockwise, sorry, this side. One, 2, 3. Direction is anti-clockwise. Least priority in horizontal. Anti-clockwise, least priority in horizontal, R. Right? Next, here it is H. Here it is OH. 1, 2, 3. Anti-clockwise, least priority in horizontal. This is having R. This is having R. So like this, OH, OH, both are opposite sides. There is no plane of symmetry. There is no plane of symmetry, that is having which one? Active. Now RR, if it is there like this, SS will be there. How to write this SS? Methyl, OH, H, HOH, methyl. For this one. 1, 2, 3. Direction is clockwise, least priority in horizontal, that is S. Direction is 1, 2, 3. Direction is clockwise, least priority in horizontal, S. This is which one? Active compound. There is no plane of symmetry, right? Active compound. These two relationship is which one? This one. And this is third. One and third relationship is which one? Enantiomer. One and third are enantiomers. Single chiral center, RR, SS. Right, now here it is, this one. R it may be there, how to write this? R, H, OH. Or you may say that directly similar bonding connectivity is there. RS, it may be there, that is having meso. Directly you can say that. Or you go for this, HOH, methyl. Because S configuration is there, HOH. R configuration is there, HOH. Right? We don't need again. So here it is already mentioned that. This is having which one it may be there? Plane of symmetry is there. One is R, one is S. Chiral centers will be there and having plane of symmetry is there. This is which one it may be there? Meso. So this is also similar compound. This is also similar. Homomers it may be there. Plane of symmetry and chiral centers will be there. Meso compound. If it is another one compound is there, identical. That is having same. Methyl. This is having which one it may be there? HOH because yes. Here it is OH, H. This second one is R. Second one is R. Second one is R like this. HOH. Methyl. It is also which one it may be there? Meso. And the second one and fourth one is having homomers. Second and fourth are homomers because it may be same. This one is same compound while if it is rotation takes place. If it is 180 degrees rotation takes place, these two are having same homomers. This is active compound. And this meso-active relationship is which one? Second and first relationship is a diastereomer. This meso-active relationship is diastereomer. Again, this is also diastereomer relationship, right? Like this, you go for RR. It may be there having active. RS will be there. SR will be there. That is having meso. Same molecule. Bonding connectivity is same, right? If it is methyl and another one substitution is there, it is not meso compound. It may be enantiomer. It may be there. Right? If it is COH is there, it may be meso. Methyl, phenyl is there, meso. But here it is CHO, CH2OH is there, it is not that. Because there is no plane of symmetry. The plane of symmetry, if it is there only, that rule if it is applied. Right? Must and should. Right? Next one example is like this. Here the chiral center will be there. Here chiral center will be there. Chiral center will be present in that molecule. Where chiral center or chiral center will be there in that molecule, this position is chiral center will be there. There is no other position. 4 different groups is not there. So this position it may be there. So you give the numbering C, CH2, CH2, but here it is C, but double bond it may be there, here it is there. So 4 bonds which here it is double bond, carbon it may be there, attached link it may be more carbon, and again duplications carbon it may be there. CH3 connections that may be different based on the atomic numbers. This is first priority. Now CH2, but here it is double bond may be there, duplications will be possible. So here it is second priority, this is third priority. So direction is which one? Anti-clockwise. Thick line it may be there, indicates hydrogen is in away from the observer, dotted line. Hydrogen is dotted line. Hydrogen is dotted representation or broken wedge it may be there, that is away from the observer. Least priority group is 4 group, hydrogen. So if it is thick line, hydrogen is dotted line. If it is dotted broken line, hydrogen is thick line. Because here it is, but here it is because the HNO is one is out of plane. The groups are out of plane means one is above the plane, one is below the plane. This is above the plane, another one hydrogen is below the plane. Or this is nearer to the observer, that is away from the observer. Based on that 1, 2, 3 anti-clockwise direction, least priority group is away from the observer. So that is which one it may be there? Yes. And here it is also same. 1, 2, 3 anti-clockwise direction, but the difference is which one? This priority group is, first priority group is away from the nearer to the observer, then away from the observer. Then which one it may? Hydrogen is nearer to the observer. One is away from the observer, hydrogen is nearer to the observer. This is below the plane, above the plane. So least priority is in nearer to the observer, rules are reversed, then clockwise is anti-clockwise, then it is R. One is S, another one is R, similar bonding connections will be there. These two are opposite configurations will be there. These two are enantiomeric relationship. Enantiomeric relationship. Methyl, here it is. Which one? These two are enantiomeric relationship again. But configurations are what? Here it is 1, CH, CH, CH2, CH2. And go for this. What will be happen? Here it is, duplications will be takes place, double bond. Here it is C. Here it is, already it is there. Here it is C, it may be there. C and C. Like this. Here it is double bond O, that means that C, here it is C. You go for that connections. CH2, CH2, and here it is C. This is going to be C, this is oxygen. Here it is oxygen, it may be there. It is carbon, but here it is oxygen. So which one you get more priority? 2 and 3. So then which one? Anti-clockwise. Least priority in anti-clockwise, least priority near to the observer, then it is R. Here it is S. R and S will be there. Which one it may be happening? These two are enantiomeric relationship. These two are enantiomeric relationship. It is maintained. These two are enantiomeric relationship. Right. Next one atom. Example, suppose it is given like this, O methyl H or methyl H. or OHH, suppose. OHH. How can you give in that? Here it is chiral center, asymmetric center. Here it is also chiral center or asymmetric center. If it is given, the hydrogen is what, which line it may be there. So you take this rotation to the 90 degrees in plane rotation, 90 degrees rotation takes place. Then this molecule is going to be like this. HOH, this direction, 90 degrees rotation takes place. HO-methyl. HO-methyl. 90 degrees rotation takes place. So then what will be happening? 1 and CH2, but here it is CH2 is there, here it is O is there. So second priority, third priority. Direction is which one? And clockwise. Direction is clockwise. Direction is clockwise. Least priority in horizontal, this is S. This is automatically 1, 2 and 3. Direction is anti-clockwise. Least priority in horizontal, which one it may be there? R. Like this, you have to, if it is given like this, for better understanding in the molecule, you rotate that 90 degrees, you convert them, going to be like here, this molecule is there, if it is rotation takes place, going to be rotation takes place, right? This group, if it is there, the direction of the methyl, O-methyl will be changed to this. O-methyl is going to be from this position to this position. Just this will be happening, right? 90 degrees rotation. 90 degrees rotation will be takes place. Then it is which one? That group is considered as. If it is next another one, suppose another one example. OH, 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 you practice them. OH, CHO, CH2OH. What is the, how many chiral centers are there, asymmetric centers are there? What are the configurations? What are the configurations? Like this configurations are what? You can practice that, right? I will give 1 or 2 examples, you can practice that. What is the configurations of these following examples? Chiral centers configuration is what? Here chiral center, here chiral center, here chiral or asymmetric centers will be there. For this molecule, 4 chiral centers or asymmetric molecules are there. Now, how can you, so which one is the configurations? Which one is the configurations? Sometimes 1, 2, 3, 4, numbering is also given. But which one it may be the configurations? For here, 1, first connection is oxygen is more atomic number. Next you go for that CH. Here it is connecting with the OH, no problem. Here it is another one, here it is CH, okay. OH is okay. But another one connection is hydrogen. For another one connection is carbon. Like this. CHOH. In places CH is there, but here it is carbon it may be there. So it is more. Right? So that's why it is numbering is 2. This is 3. Direction is which one? Anti-clockwise. OH is in the broken wedge. That means here it is nearer to the, away from the observer. Hydrogen is nearer to the observer. That means least priority group is nearer to the observer. Rules are reversed. That means horizontal line. So it is going to be clockwise. Direction is clockwise. Least priority group is nearer to the observer. So that's why here it is yes. From this 1 CH2OH is same, but CH2OH here it is OH CHO. So it is more. This is 1, 2, this is 3. Direction is which one it may be there? Anti-clockwise. Direction is anti-clockwise. OH is nearer to the observer means least priority hydrogen is away from the observer. So anti-clockwise direction is there, so that's why yes. Here yes, here yes, here. 1. Priority directions. CHOH, Here it is CHO is there, here it is OH it may be there. Which one you give that? OH, here it is CHO is there. CHO meaning is like this here. That means here oxygen, here like this. Right? COH, one side. So oxygen it may be there, further there is no connections. But here it is oxygen, hydrogen it may be there. You go for that another one position is CO, it may be there, CO is enough. CHOH is okay. With respect to, sorry, which one? This one. With CHOH is okay. For here, CHO and CHOH. CHOH is there and here it is this type of connections. CH, here carbon it may be there. Right? Which one is the numbering is given? So you give the numbering is 1. Suppose if it is clockwise direction or anti-clockwise direction, which one is given? So similar like this, duplications it may be there. Instead of CH2OH, here it is duplication is there, CHO is there, so that is going to be more because both sides, oxygen it may be there. Here it is one side is O, but another side is carbon it may be there. So that's why 2, 3, direction is anti-clockwise. Direction is anti-clockwise, least priority group in nearer to the observer. Sorry, direction is clockwise, least priority group is nearer to the observer. Clockwise nearer to the observer is S. This is also S. This one is which one? 1, COH, this is CHO. COH it may be there. Another one side is carbon, one side is oxygen. But here it is both sides will be oxygen, it may be possible due to the Pantham numbers. Duplications it may be given. Duplications, right? So because unsaturation may be there. So 2 and 3. So direction is which one? Anti-clockwise. Like this, least priority group is away from the observer. This is S. All are S configurations. All are S configurations. CHO means C11O, H means like this. Both sides are oxygen. This one side is oxygen, but another one side is carbon, it may be there. Not like this. So this one, here OH is 1, CH2, OH, CHOH, CHOH. Here it is hydrogen is there, but here instead of hydrogen, CHO is there. So you give the priority is 2, this is 3. Clockwise, least priority group is away from the observer because hydrogen, because this is OH is away, near to the observer, hydrogen is away from the observer. Clockwise is R. This one is which one? 1, CHO, COH, another one side is carbon, but here it is like this, so 2 and 3. Direction is anti-clockwise. Again, least priority group is away from the observer, so S. One is R, another one is S. Similar to like this, this is R. First priority, second priority, third priority. Direction is anti-clockwise, but least priority group is nearer to the observer, so it is R. Like here, 1, 2, 3. Direction is clockwise. Direction is clockwise, least priority group is nearer to the observer. So this is S. Similarly, here it is. Direction is anti-clockwise. Least priority group is away from the, nearer to the observer. Anti-clockwise, nearer to the observer, this is R. Like this. Now here it is like this, S. This is like this, S. R, S, R, R, S, 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 R will be there. Here there is no plane of symmetry because CHO and CH2OH. This group is CH2OH. CHO one side, CH2OH one side. Right? CH2OH, another one side is CHO is there. OH, OH it may be there. So based on this, suppose this is 1, this is 2, third and fourth. What is the relationship of 1 and 2? RS, SR. RS and SR. Which one relationship is there? RS and SR relationship. There is no plane of symmetry. There is no plane of symmetry. One is R, one is S. Another one is S, another one is R. There is no plane of symmetry. That means here it is different group, here it is different group. If it is same, it may be there. That is having which one? Homomers. Plane of symmetry if it is there. But here it is different groups. That is having different groups. Here. So these two are which one relationship? And if it is sigma is there, homomers. Right? Identical. But here it is, these groups are different. CH2OH. So that's why these enantiomers. And to our enantiomers relationship. 3-4 relationship is what? RR, SS. This is R, this is R, this is S, this is S. So absolutely these two are enantiomers. Three and 4 are enantiomers. Now these two relationship is two relation. One is RR, RS. RR and SS will be which relationship? RR, SS, RS. These two are absolutely diastereomer. These two are 1 and 3 is diastereomer. 2 and 4, these two SR, SS. It is also diastereomer. 1 and 4th relation, this one RS, SS. It is also diastereomer. 2 and 3, these two SR, RR. These two are also diastereomer. Only two enantiomeric pairs, 4 diastereomers. Number of diastereomeric pairs are more than the enantiomeric pairs. I mentioned that earlier one. Right? For a selected pair, selected molecule, only one enantiomeric pair is possible. But for this selected molecule, diastereomeric pairs are more. 2 diastereomeric pairs here it is possible for this example point of. Now, another one more, suppose this one. What is that configurations? How many chiral centers will be there? Here chiral center, CH2, CH2, but here it is OH. This connection is different, so here it is chiral center, methyl, CH. These are all the other different chiral centers. 3 chiral centers will be there. For this one, CH is same, but here it is tertiary type carbonate may be there, so it is given 2. This is 1 and 3. Direction is which one? Anti-clockwise. Least priority group is away from the absorber. So which one it may be there? Because OH is nearer, hydrogen is away from the absorber. So this is S. Here which one is there? CH, CH2, CH2. But here it is CH, C and carbon linkage is there. One side is double bond O. So that's why you can give the priority is 1. And next CH2, CH2, but here it is OH linkage, but here it is not there. So you give the priority 2 and this is 3. So direction is anti-clockwise. Direction is anti-clockwise. Least priority group is in away from the absorber. So that's why here it is S. Now what is that here? It is also least priority group is hydrogen is away from the absorber. Because this is already mentioned thick line, H it may be there. So which one it may be given numbering? Here it is methyl, it may be there CH3, and here it is C. So you can select. This is not the first priority, this is not the first priority, these two cases, which one it may be there. So here it is carbon, 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 like this it may be there. CH2, CH2. Next in another one case, which one here it is? This one case. C, O, O, it may be there, C like this. CC is same. Next connection is CC, but here it is O connection is there. So that's why you give the priority is 1. Then go for this second, go for this third and 4. So 1, 2, 3 and 4. 1, 2, 3, 4. Least priority group is methyl here. Not hydrogen. Least priority is methyl because already 4 substitutions will be there. Least priority group is methyl. Least priority group is not hydrogen, methyl. Least priority group is methyl, but the least priority group is in nearer to the observer. Nearer to the observer. Then rules are reversed. This is clockwise direction, nearer to the observer, that is S. Right? All are S configurations. All are S configuration. Right? Next one, suppose here. How many chiral centers? Only one chiral center here. This is HO means C11OH. C11OH. Which one is the first priority group? Carbon, carbon, carbon. All are same. These two are OH connections. Here it is also OO connection, it may be there. But HH is there, but here it is methyl group is there. So definitely compared to this, this is top priority. Now these two cases, which one it may be there? If it is given duplications, what will be happen? O and here there is no bond will be there if it is given like this. For these two cases, which one it may be there? C, definitely CH is there because hydrogen is there. One side is O, another one side is O. It's okay. Because ending. It is in horizontal, so that's why here it is R. Which one it may be there? R. Clockwise, the grouping. Sorry. Rules are reversed. Horizontal line. This type of example may be there. Right? Next.